What's the probability it will snow today? First of all, what does certain mean? Who remembers from the video? Yeah. It's for sure going to happen. There's no doubt. So if the question had been, what's the probability it was going to rain today, what would your answer be? Sure. Because it's already happening, so it's for sure happening. What does likely mean?
It means it probably will happen, but it may not happen.
Yeah, so there's a pretty good chance, right? What about not likely?
It means that it's probably not going to happen, but it might.
So there's a small chance, but it still could happen. And impossible? What? It won't happen. So what if it had been, what's the probability it will be sunny today? What would our answer have been? Impossible. But since it says, what's the probability it will snow today, what's our answer? Certain? Is it snowing right now? Likely. It's not snowing right now, so it's not certain, but it's probably going to.
It already did snow.
It has not snowed.
It did snow.
We had a little bit this morning, but not, we had a teeny bit this morning.
Okay.
Not a lot. It was mostly sleet. It looked like snow out there.
That's what I
I think that was mainly like a sleet. Yeah.
Okay. That's kind of what we were talking about. If it's certain, it's 100% absolutely positively going to happen. If it's impossible, there's no way it's going to happen. There's absolutely no way we're going to end up in Florida this afternoon. Right? It's not going to happen. Likely, it's probably going to happen, but it might not. And unlikely, it's probably not going to happen, but there's a small chance. What would equally likely be? There's a 50-50 chance. So, like we were talking about with the quarters, if I flipped a quarter, it's equally likely to land on heads or tails, right? Okay. We're going to talk about some definitions really quick. What's an event? Kind of a trick question. Caroline? Something that happens.
Good definition.
So when we roll a dice, that's our event, and it has more than one outcome. We can land on a 1, 2, 3, 4, 5, or 6, but that's our event. What's the outcome? I kind of just gave that away.
It's okay.
Ty?
What happens?
What happened?
An event.
I like how you included it in the event. The outcome is what happens as a result of the event. That makes sense? So it would be landing on the 1, 2, 3, 4, 5, or 6. What's an experiment? Arwa?
You're doing something?
You're doing something. Okay, so if we were to actually roll the dice and see what it lands on, that would be our experiment. We're actually doing it. What's probability? What's the definition? Does anybody know? We talked about it a little bit. Yeah.
Something that will or will not.
So,
There's a good word for that. Can you think of a good word? If something could or could not happen, what's a good word for that? There's a good synonym for probability. Well, I know it sounds like, probably does sound like probably, but it probably means it's probably going to happen. So what's another good word that for probability, a synonym? Yes.
Chance.
I agree. I think chance is a great synonym for probability.
chance of an event occurring. We already know what an event is. Okay, so when we write probability, we're going to write the number of favorable outcomes over the number of total outcomes. So, for example, if we're rolling our dice one time, and we want it to land on a 3, there's only one 3. We can only, if we roll it once, and we want a 3, there's only one 3 on that dice, right? How many other numbers could we land on? How many sides are there on a dice that are possible? Calvin? 6. So we want 1, but we could get 6. Everyone understand how we got that? Okay, the experimental probability is if we actually roll the dice. Okay? So, in theory, we'll land on a 3, 1 every 6 times. right? If that was a perfect world, we roll it 6 times, we land on each number 1 time. But that might not happen, right? We could land on 3 every time, or we could not land on 3 at all. So our experimental probability is going to be when we actually roll the dice, how many times we land on it. Okay? Let's practice that. Here's our spinner. What's the probability that we'll land on a red? There's 1, 2, 3, 4, 5, 6, 7, 8 cards. What's the probability we'll land on a red? 2 out of 8. What's the probability we'll land on a green? Tell me. 1 out of 8. What about a purple? Riley? 2 out of 8. They know to reduce yet. Okay. What about a white? 1 out of 8. Gray? Blue?
1 out of 8.
And blue. 1 out of 8. Which of these colors are equally likely? Give me 2 that are equally likely. Red and purple. Because we know that there's 2 reds and there's 2 purples. Are those more or less likely than landing on a green? More, because there's more purples, right? Okay. Now we're going to spin the spinner. Okay? So ideally, we'll land on a red 2 times out of every 8. But if we spin it 8 times, we might not land on it that many. We're only going to do 8, because how many times we have. There's 1 red.
Yeah, you put the pen down first. Yeah, I know.
That should be a hassle. 1 blue.
What is she doing right now? This would be our what? Yes. Okay, what vocabulary word would we call this? Yes, Carolyn. This is our experiment. Very good.
If I spun this 8 more times, would I land on these same ones I'm landing on right now? Probably not. Who said that? You did. We don't know what we're going to land on, do we? And it could be different every time. We landed on blue 3 times. But we thought we'd only land on it once. So our experimental probability is going to be different every time.
It's a little, I know. I'm sorry.
There you go. Okay. We didn't land on purple at all, but it was equally likely as red, wasn't it? Okay. Let's do heads and tails. What's the probability we'll land on heads? Caroline? 50%, or 1/2. Because, how'd you get that?
We'll have the coins head and half of its tail.
Right, so we want heads, one outcome, but there are 2 possibilities, right? What about tails? What's the probability of landing on tails? Yeah?
50%.
So also 1/2. Why are they equally likely? Why isn't one more likely than the other?
Because
There's
there's only 2.
only 2 sides. If I flip this coin 5 times, or we'll do 6. If I flip this coin 6 times, will I land on heads 3 times and tails 3 times? No. Maybe? Who said it? We don't know what we're going to land on, do we? Let's see. Tails. Your brain stopped it. Tails. So already we've landed on tails more than heads, haven't we? Wow.
Maybe
Maybe we'll
put it. Yeah, maybe it's put to the tail.
It's not.
No, it's not.
It's not. It's just probability. Does this mean that we're more likely to land on tails now?
Yes.
Yes.
Does it?
No.
Are we more likely to land on tails?
No. Yes. No.
If we flip this coin, are we more likely to land on tails?
No.
No. Just because we landed on it all the other times doesn't mean we're going to this time, does it?
No. You might.
We might.
Right, it's possible.
It's a problem.
Oh!
There's the head one.
Come on.
Sometimes if you move the whole thing over a little bit, it'll help you. There you go. There you go.
Okay. A pail contains 8 red marbles, 5 blue marbles, 6 green marbles, and 3 yellow marbles. If a single marble is chosen from the pail, what is the probability it will not be red? Okay. What strategy are we going to use to figure this out?
What do we need to do first?
Alvin? Probability. How are we going to find out the probability that it is not red? Caroline, what's our first step?
Looking at all marbles and seeing how many there are.
Right. We have 8 red, 5 blue, 6 green, and 3 yellow. How many does that make total? Eliza? 22. We have 22 total. And how many are red? Ty? 8. 8 are red. That's not our problem. So if 8 are red, how many are not red? 14. So the probability of it not being red are the number of marbles that are not red, which is 14, over the total marbles, 22. What's the probability we will choose red or yellow? We learned that yet?
That's a good one.
Okay. How many red are there? We already know this one. How many yellow are there?
3.
Do they know how to?
No, good.
I will. Okay. 8 plus 3 is what?
11.
So 11 out of our 22 marbles will give us what we want, right? We have a 1/2 chance of drawing a red or a yellow. Okay? What we're going to do, do the dice game or the worksheet?
That's up to you. Whatever you want.
Yep.
That's how I want to play the game. Yeah.
Okay. We're going to give you guys a paper. You're going to find the probability of flipping each color, of rolling the dice and landing on each number. Okay? So there's a 1, 2, 3, 4, 5, and 6 on a dice. Are those going to be equally likely chances?
Yes.
Yes. Then you are actually going to flip the dice. How many times does it say 10? I don't know how many times it says. You're going to roll it that many times and tally how many you land on each color, or on each number. And then you're going to go through and write the experimental probability. Will the experimental probability be different or the same as the theoretical probability?
Well, because she's giving directions right now, and I'm afraid that if your brain is not in and you're not listening, you're not going to know what to do. Because this is different on each section.
Okay. The first section, we're writing whether each number is certain, likely, not likely, or impossible. Is it certain that we'll land on any of those numbers? Is it certain we'll land on what? No.
Yes. No, we can't guarantee that, can we?
Is it impossible though? No. So they're all probably going to be likely, aren't they? We have an equal probability of landing on all 6 of them. For theoretical probability, how many ones are on that dice? On that die? 1. How many total numbers are there? 6. So what's our theoretical probability? 9. 1 over 6. We have one that we want, but there are 6 total. Is that going to be the same or different for the other numbers? Same, because there's only one of each number, isn't there?
You should be filling this. You could be filling that out right now as we're doing it. You should have we already said they're all going to be likely, and then we just gave the theoretical probability for each one of those.
Then we're going to roll our die 20 times. Will we get the same 20 numbers? No. So will our experimental probabilities be different? So how do we find those? You're going to take the number of times you landed on that number and put it over 20. That's how many times you did these. Okay? Go ahead and start working on it. I know. Bring them around.
No, there's no sharpen.
There's not. Can you just sharpen one?
Yeah, go ahead. Sharpen it. Sorry, good.